In this lesson, we want to talk about motor controls. At the end of this lesson, you should be able to describe the differences between a relay, a contactor, and a starter. You should be able to say how locked rotor current of a motor affects the choice of a motor starter. We should be able to list the basic components of a contactor and a starter, and you should be able to compare two types of external overload protection. You should also be able to describe the conditions that must be considered when resetting safety devices to restart electric motors. Relays, contactors, and starters pass power to the motor by closing a set of contacts. Contacts controlled by the coils in the control circuit. Starting relays are only in the active circuit for short periods of time. The type of motor control used is determined by the size and application of the motor. The higher the amperage, the heavier the control. This is an example of a relay or contactor. L1 and L2 pass through a set of contacts. They're normally open, and the control circuit energizes the coil, which then in turn shifts the position of the contactors and allows electricity to flow. The start winding is only in the circuit for a short period of time. There's different motor amperages to deal with. First of all, running load amp, RLA, is similar to full load amperage. Amperage is drawn by the motor while operating. Locked rotor amperage is the amperage drawn by the motor at startup, 5 to 7 times greater than the RLA. Both LRA and RLA must be considered when choosing a control device. The relay has a magnetic coil to open or close one or more sets of contacts. The relays are not repaired. They were replaced on failure. They're used for light-duty applications, and they can be used as a pilot-duty relay. In other words, one relay controlling another. The relay contacts must be able to handle the amperage draw of the load being controlled. This is a set of relays. We have a coil. We might have a normally open contact, or a coil and a normally open and a normally closed contact. The contactor is a larger version of the relay. It has movable and stationary contacts. The holding coils are rated at different voltages. It can have one or more sets of contacts, and some are even equipped with auxiliary contacts. In other words, a set of contacts that's either normally open or normally closed based on the position of the main contacts. In the contactor, the contacts in the coils can be replaced, but we want to use an exact replacement whenever possible. Okay, we have the coil connections. We have the holding coil, then we have our stationary contacts, and our movable contacts in armature. Onto these, and then when they're closed, it comes down and it makes your contacts. When the coils are energized, the contacts are pulled closed. Looking at it from the side, you have your stationary contacts, you have your movable contacts. We have springs that pull them back into place. We have a coil, and we have a stationary electromagnet, and we have the armature. And you see how they're pushed into place. Motor starters are contactors equipped with overload protection. The coils, the contacts, and the heaters can be replaced. Contacts do become pitted over time. Pitting increases the resistance across the contacts. The voltage across the contacts will increase the more pitted they become. In other words, they start using voltage. Anytime we have a resistive load that's using voltage, we're going to have heat. The voltage across a good set of contacts should be about 0 volts. Looking at this picture, you can see the difference between a clean contact and a dirty pitted contact. The dirty pitted contact will start generating heat along with resistance. Motors are expensive and must be protected. Fuses and circuit breakers protect the entire circuit, not the individual circuit components. Motors can operate under overcurrent conditions for a very short period of time. A lot of small motors don't have any overload protection because they're cheap and easy to replace. The larger the motor, the more elaborate the method of motor protection should be. Motor protection can be inherent, which is internal, or it can be external. And if we look at this picture, we have a small 3 amp motor. that's attached also to the same circuit as a large 25 amp motor. That large 25 amp compressor motor in this case is a lot more expensive to replace than the small 3 amp motor. Inherent motor protection are internal thermal overloads. They're usually embedded in the motor windings. They'll open on a rise in temperature. They can also be thermally actuated bimetal discs. They're positioned so the contact is made between the bimetal control and the motor. The snap action opens contacts if the motor temperature rises above a desired level. Either way, they shut off the motor. External overload protection are devices that pass power to the holding coil of the starter or contact. They open when an overcurrent condition exists. They're all done on amperage. The trip point and the type of overload protection are determined by the manufacturer. The overload device takes the service factor of the motor into consideration as well. Remember, the service factor is the additional capacity that a motor has. National Electrical Code sets the standards for electrical insulation. They talk about conductor sizes and amps, the cable and the material and the applications, and they set the standard for electrical devices. It sets the standards for motor overload protection. The published code book should be consulted if any questions or concerns are encountered on the job. Temperature sensing devices used in motors are bimetal elements. These devices are called heaters, wired in series with the load. The heater is exposed to current draw of the load. The bimetal warps and opens as it gets too warm. The open bimetal de-energizes the starter on the holding coil. There's a second type called solder pot. It uses solder with a very low melting point. When the solder melts when excessive temperature is sensed, excessive heat results from this overcurrent condition. Many times the solder pot sensing device must be replaced if this overcurrent condition happens. The bimetal devices will reclose once it cools. This is an example of a temperature sensing device. That's a solder pot. Okay, the overload heater heats the solder, and then once it opens, once the solder melts, the spring will pull the contact back down. Magnetic overload devices are accurate means to provide overload protection as well. Device is not attached to the starter. The device is not affected by increased ambient temperatures. The contacts within the device will open to de-energize the motor at an amperage level, not heat. This is an example of a magnetic overload device. Notice the large winding there in the center. It captures the high amperages, but does not have much of a voltage drop, so it can be wired in series with the motor. Once a motor trips on an overload protection, it should not be restarted immediately. Cause for the overload condition must be first located and repaired, and the motor should be given ample time to cool. Manual control devices are manually reset. Some controls reset automatically after a predetermined time delay. The time delay feature prevents short cycling or the constant on and off of a motor failing. Bottom line is, the motor will not fail on its own. There's some cause that actually you need to find before you reset a motor. So we've talked about relays, contactors, and starters. They all pass power to motors. Contacts controlled by control circuit holding coils, or just the relay coil or contactor coil. Relays are used for light duty, contactors for heavy duty, and starters have built-in overloads. Contacts on contactors and starters can be replaced, not in relays. If a contact goes bad in a relay, replace the relay. Fuses and circuit breakers provide protection to the entire circuit, not individual circuit components. And motor protection can be inherent, which is internal, or external.